Morning, guys. We're going on to 8.5, where we talk about, what do we talk about here? Solving problems involving the circumference of a circle. Let me get the paper here. Now, this is a fun one because it involves string. So super fun. I know you guys don't have string, so kind of just like pay attention to the values that I put on here. But anyway, the distance around a circle, if I could get this focused up, and the distance across a circle are related. If you're interested in circles, you might be thinking, oh, pi, you're right. So use string to measure the distance across each circle. How many of these lengths does it take to go completely around the circle? Of course, I just lost the string that I had here. So I'm actually going to measure this with a ruler. So the distance across here is about 3.8 centimeters. For the dartboard, let's see, distance across 3.8. And so we're going to use a piece of string to measure kind of around it. So I'm just going to start here, and I put that right there, 3.8. Sorry, guys. Let me get this closer to me. It'll probably be easier. So I'm just going to kind of measure around with the string, kind of put it on there. This is going to kind of be a rough estimate, of course, because the string is not how you want to measure these types of things. But okay, it's about right there. So then I'm going to take my ruler and measure it out here. So that gets me to about, come on. And 11.9 or so. Okay. And again, this is like kind of a rough estimate, just because, it's a string that you're measuring with, which is not the best way to measure these types of things. And these aren't the real sizes for these things. It's about 2.5 centimeters for the distance across the circle for the disk. And let's just do the button as well. We get about 1.3 distance across the circle. So now let's do the disk and then the button. Again, these are very rough estimates here as we measure these. Okay, let me bring this kind of down here. So we get about right there. This is for the CD. You guys know what CDs, compact discs, are? Yeah. It's about 9.5-ish. Okay. 9.5? Let's see. Yeah, okay, we'll see. Again, these are rough estimates. Let me double check. Let me do the measurement on that again. Okay. It's about 2.5. Yeah, that's about right. Let me do the measurement on the disk again. So I think 9.5 sounds too long. So let's kind of really tighten this up. Okay, about that. There we go. That's much better. I don't know what happened there. So we're looking at about 8.2, let's say. That's better. And then this little button's going to be a pain. Okay. Again, these are, terribly rough estimates. And I don't know why the book is like, use string for this one problem and then never again. Okay, well, let's see. That's about right, probably. Let's see. This will be about 5. Close enough. Okay. So what do you notice about the ratio of about the distance of the circle around the circle to the distance across the circle for each circle? So we're going to divide these out. I'm going to take that 11.9 and divide by 3.8 and do that kind of across the board here. Divide by 3.8. Okay. It's 2.9, 11.9. Come on. 11.9 divided by 3.8. Oh, shoot, man, that's real good. 11.9 divided by 3.8 gets us to 3.13. Real close to a very specific number. Then we got 8.2 divided by 2.5. 8.2 divided by 2.5 gets us to 3.28. Nah. Again, this is, down to the roughness of the measuring technique, right? So we're going to take that 5, we're going to divide by 1.3. Then we get to 3.84. Oh, that one's way off. Again, because it's so small, it's kind of super hard to block. So they're all kind of in the threes, right? Which we get there around there. We can kind of say they are all around 3. Again, this is a very rough estimate. The ratio, the ratio are all around 3. We are looking, of course, for 3.14, which, closest one is right there. That 3.14 is pi, by the way. Okay, so this kind of goes into it right here. Mark recently replaced his front bicycle wheel. How far does the bike travel with each revolution of his new front wheel? So the diameter is 26 inches. So we list some vocabulary right here that we're going to be using in this unit. Radius is the distance from the center point of the circle to the edge of the circle. The diameter is the distance all the way across through the center, and then circumference is the distance around. Okay, so we can relate the circumference to the diameter with this formula, right? Circumference divided by distance through the diameter is equal to pi. That's kind of what we talked about in that last one. We got really close with the compact disc. I think it was easier to measure because it was bigger. Maybe I just should have made the picture bigger. Too late now because I already got the data on there, and that's what's going to be in the video. But anyway, we've got this diameter right here at 26. Okay. And so we're going to say that the circumference, we're going to plug it into this formula right here, right? So circumference equals pi times the diameter, right? And we're going to use the value of 3.14 for pi. That's just kind of like the shorthand that most people use for it because it goes on forever. It's like 3.145982, and then it goes on forever. But anyway, we're going to take that 3.14. We're going to multiply by 26, and we get to 81.64. So the circumference is 81.64 inches. Okay. And so that's the distance, right? So the distance traveled by the wheel for one revolution, the distance traveled by the wheel for one revolution is 81.64 inches. Sorry if my handwriting is terrible. And this should say circumference. I'm going to change that right here. Gosh. Circumference, the spelling's right there, if that's too hard to see right there. What is the radius, or what is the circumference of a basketball hoop with a radius of 9 inches? And so we're going to use this formula right here. That's C equals pi times the diameter. We can use the radius to kind of extend that. So it's 18 across. And so we kind of put it in there. We say C equals pi times 18, which is 3.14 times 18, which gives us 56.52. So the circumference of the hoop, circumference of the hoop is 56.52 inches. Yeah. Okay. Oh, man, I'm out of time. Okay. Kayla and Theo got on the Ferris wheel shown. About how high will they be at the top of the Ferris wheel? The circumference is 220 feet. Again, we're going to use that same formula, right? So circumference is 220 feet, and the formula we're going to use is circumference equals pi times the diameter. The diameter is basically what we're looking for because it's the height of that Ferris wheel, right? So we're going to take that C and actually plug it in over here. So the structure of our formula is going to be a little different, right? We had been working with the diameter and finding the circumference, but now we're kind of working backwards. We have the circumference and we're finding the diameter. That was a mistake. You can just cross that out. So we're going to divide by pi right here, basically, right? So we could leave it as 220 divided by pi. You're going to have to wait a few minutes. Oh, okay. Hey.
This is just for your sub plans
Okay.
because people don't, like your subs don't know who they are.
Okay.
I
Cool.
just printed one out for Peter's.
Awesome. Okay. Thank you. So we're going to take that 220. We're going to divide by that pi. So it's the same thing as 220 divided by 3.14. Which gives us 70, right? So d equals 70. They will be 70 feet high at the top. Okay. The larger gear turns twice per second. So right here, it causes the smaller gear to turn. How fast does the smaller gear turn per second? This is a few steps right here. So basically we need to find the circumference of each one. So step one is going to be the circumference of the larger gear. So we'll say larger gear, might as well. We have the diameter, right? So it's going to be C equals pi times the diameter of 6, and then the smaller gear is C equals pi times 2. So again, remember that pi is going to be 3.14, so we're just going to do everything in the calculator here. 3.14 times 6 gets us to 18.84. And then we do the same process here. We take that pi, which is 3.14, and we multiply by 2, so we get 6.28. And so now what we're going to do is we're going to take this for step 2. We're going to divide this circumference by that circumference. So this distance around divided by this distance around. And this is basically finding the how much bigger this gear is than this gear, right? Or how much smaller this gear is than this gear, right? So we're going to take that 18.84. Excuse me. And we're going to divide by 6.28. Divided by 6.28 gets us to 3. So basically, the big gear is 3 times bigger than the smaller gear, okay? And so now for step 3, we know the other piece of information is here that it causes the larger gear turns twice per second. So if this is 3 times bigger, we take that 3 and multiply by that 2. And we get to 6, right? So how fast does the smaller gear turn per second? Sorry, running out of room here. The smaller gear turns 6 times per second. There you go.